We're talking about something called compound inequalities, which you should have learned last year, but we're going to kind of review a little bit. Let me explain a little more bit. Compound inequalities are two or more. We can have more than two, but typically it's just two inequalities. And then there's two different types. One's called an OR, one's called an AND compound inequality. For the AND compound inequality, a number is a solution if it's a solution to both inequalities. That's the AND. And the OR inequality is a number is a solution to the compound if it's a solution to one or the other inequality. So let me give you an example. So we have and OR inequalities. They will either say the words and or they'll say the word or, although if it's an and, I'll show you there's another way to write them where you won't see the word and. So for a solution to the compound inequality, the number must be a solution to this and also a solution to this. So these are already solved for x. So all the solutions to x greater than or equal to 4 are all of these numbers, correct? And solutions to this, x is less than 10, are all these solutions. So solutions to this compound inequality are just the numbers that are solutions to this and this. So what on the graph is going to be a solution?
5.
Whatever is in both green and blue. Okay, so the numbers that are in both green and blue would be, is 4 in both colors?
Yes.
Yes. And then everything here, what about 10? Is 10 in both colors?
No.
No, because of the open circle there. Okay. So this is the solution set to that compound and inequality. And so the solution set, of course, that's the graph of the solution set. The actual solution set in interval notation would be all the numbers between 4 and 10, including 4, excluding 10. This compound inequality could be written in one line. Okay. If that's not the best way of writing it. Let's do it this way. That's this guy right here, right? And then if I flip this guy around, same thing as 4 is less than or equal to x. So we can just put this guy right here. So if you ever see something like this, that's a compound inequality. 4 less than or equal to x less than or equal to 10. Oh, was it less than 10? Okay. This is two inequalities in one, a 2 for 1. Okay, if you ever see two inequalities in one, it's a compound and inequality. It has to be a solution to this and a solution to this. Where OR inequalities have to be written separately, you have to use the word OR in between. So x is greater than or equal to 5, or x is less than 0. You always see the word OR in between.
Okay.
So in orange is the solution to the x is less than 0. Green is solution to x is greater than or equal to 5. So the solutions to the compound inequality is the ones that are in green or orange, which are all these. Okay. And then to write this in interval notation, we have to write two separate intervals. So from negative infinity to 0 and 5 to infinity, which are two different sets. And how do we join them into one set? Did I teach you guys this? Maybe. Yeah. So we put the this big U looking thing, stands for union. All that means is these are two separate sets. To combine them into one set, you put a union sign in between. Now this is one big set, even though it's two separate intervals. Is this an or an and compound inequality? Or definitely, we see the word or. So solutions are this, all the solutions to this, or solutions to this. Which for each of these we got to do a tiny bit of work. What do we do? Divide by 3. Subtract 6. 14. Okay. So solutions to the compound inequalities is everything we see in red. So in interval notation, negative infinity to 4, union 14. Is this an and or an or? And. How do we know?
It's like it's choices together.
Yeah, we got this inequality. We have this inequality. A solution is a solution to the compound inequality if it's a solution to the left inequality, and it's a solution to the right. Okay, the beauty about these is we don't have to write two separate ones. We can solve it all at the same time. So first is we subtract 6 from all three sides, which is really from each side of the two separate inequalities. So we get negative 10 plus the 2x plus 0 is less than 4. Then we use the multiplication property of inequalities, or division, divide by 2, divide by 2, divide by 2. So this one, x is less than 2. That. This one, which same thing as x is greater than or equal to negative 5. Is all this. So the solution set has to be both in green and red here. So is that set of numbers, which is only one interval.
So it's all the numbers between -5 and 2, excluding 2, including -5. Question?
So is the solution set where they overlap?
Yes, but also outside.
Okay. It's not just where they overlap. It's all the solutions to this, which is everything in blue or everything in purple, whatever color that is, which is
All real numbers.
all real numbers. So we gotta be careful. Just because it overlaps, the solution set is not where it overlaps.
It's very important. It's a solution to this or it's a solution to this. So the solution set is all real numbers. This would be the graph of the solution set. In interval notation, negative infinity to positive infinity. So be real careful whether it's an or an and. Just because it overlaps does not mean it's the solution set is where it overlaps. Okay.
Does the solution set those two intervals?
No.
No.
It has to be both in purple and in blue. And there are no numbers in purple and blue. So what is the solution set?
No solution.
The solutions, there are no solutions, but what is the solution set?
Oh, just the set containing there's nothing in there.
Yeah, the empty set. Either that or we write it with curly brackets. Okay. So,
Be real careful. The and the or make a big difference. There are no numbers. They're both solutions to this and solutions to this. So there are no solutions. There is a solution set, the empty set.
let me pass out the homework and stop here.